Thanks for joining me for the probability tree diagrams video. I have two examples to show you how to make a tree diagram for probability and use it to calculate certain probabilities. So let's look at the first example. I leave late for work on average 1 day out of 10. If I leave late, the probability that I am late for work is 0.3. If I don't leave late, the probability that I'm late for work is 0.01. Create a tree diagram for the above scenario. So there's two possibilities for the first branch, or the first set of branches, I can say. Either I leave late for work or I don't. So, leave late or leave on time. So those are the two options. It says I leave late 1 out of 10 days. So you can put that as a fraction. I leave late 1 out of 10 days, or you can put it as a decimal, 0.1. Now there's only two options. Either I leave late or I don't. So if I leave late 0.1 or 10% of the time, or 1 out of 10 times, that means I leave on time 9 out of 10 times, because these two things have to equal 1, because it either happens or it doesn't. So if there's 1/10 of the time I leave late, that means there's 9 days out of 10 that I don't leave late. So again, you can do it as a fraction or a decimal. I prefer decimals, but the fraction shows us how we get there. Okay, so that's all from the first sentence. So again, notice it only gave me the 1 out of 10, but you know that the two branches together have to add up to 1. So you just did 1 minus 1/10 to get the 9/10. Okay, next it says if I leave late. So that corresponds to this. If I leave late, then there are two options. Okay, so if I leave late, the probability that I am late for work is 0.3. So this is late for work or not late for work. Okay, so late for work is 0.3. Again, these two branches have to add up to 1 because it either happens or it doesn't. I'm either late or I'm not. So if I'm late for work 0.3, 1 minus 0.3 is 0.7. So I'm not late for work 7/10 of the time. Okay, so that takes care of that second sentence. Again, notice it only gives me one of those branches, and then I have to know that the two branches need to add up to 1. Okay, the next sentence, if I don't leave late. So here is I don't leave late, and I labeled it leave on time, but same thing. So if I don't leave late, there are two options. I'm either late for work or I'm not late for work. So these two branches need to add up to 1 because it either happens or it doesn't. I'm either late or I'm not. So the probability that I'm late for work is 0.01. So 0.01 is the probability that I'm late for work if I left on time. Since these two branches need to add up to 1, I would do 1 minus 0.01 and I would get 0.99. So this is a tree diagram for the information given, and we can now use this information to answer questions B through E. So B, what is the probability that I get to work on time if I don't leave late? So if I don't leave late, let me unhighlight these. What is the probability that I get to work on time? So if I don't leave late is an important place to start. So if I don't leave late, so that's this bottom branch. Then out of the two options, so out of these two options, what's the probability that I get to work on time? So it means I'm not late for work. So that probability would be 0.99. Okay, so if I don't leave late, that's the bottom branch, then out of those two options, what's the probability that I get to work on time? And that would be 0.99. Part C is similar. It also has an if statement at the end. So what is the probability that I get to work on time if I leave late? So if I leave late is the top branch. Given that I leave late, I have two options. I'm either late for work or I'm not. It wants to know what's the probability that I get to work on time. So that would be I'm not late for work. So that would be 0.7. Okay, so 0.7. Part D, it does not have an if statement. It just says, what is the probability that I get to work on time? So I'm interested in finding kind of the combination here. I want to know the probability overall of me getting to work on time. So if I look, that's the last set of branches. If I get to work on time, that means I'm not late for work. So what you have to do is look at the combination of branches. So if I leave late, let's look at the top one first. If I leave late, there's a 0.1 chance of that. I am not late for work. There's a 0.7 chance of that. So to find this combination here, so leave late and not late for work. Leave late is 0.1 and not late for work is 0.7, and when I multiply those together, I get 0.07. Okay, something similar is going to happen for the other branch on the bottom. I'm going to have, I'm not late for work, but I did not leave late. So if I leave on time, so did not leave late is another option, and not late for work. So there are two ways I can be on time for work. I can leave late and be on time, or I can not leave late and be on time. So this one would be 0.9 times 0.99. And so that is 0.891. And so now to find the overall probability that I get to work on time, I simply add those two together. So 0.07 plus 0.891, and I would get 0.961. So the probability that I get to work on time, regardless of if I leave late or not, is 0.961. So about 96% of the time, I get to work on time. Part E, what's the probability that I am late to work? So now we're looking at the other end of the branch. We're looking for late for work. So this is a late for work, and this is a late for work. So I can be late for work if I leave late. So leaving late and being late for work would give me 0.1 times 0.3. So 0.1 times 0.3 is 0.03. And maybe I should have written this down here. I'm going to do it all the way down. 0.1 times 0.7, even though I don't need that in this instance. That way I have them. 0.9 times 0.01 gives me 0.009, and 0.9 times 0.99 gives me 0.891. So in this case, what's the probability that I am late to work? I'm just looking at the ends, the late for work Here's one probability. That's if I leave late, I'm late for work 0.03 or 3% of the time. What's the probability that I'm late to work if I don't leave late? Is 0.009. So I'm going to add those two numbers together. So 0.03 plus 0.009, and I get 0.039. Let's look at a second example. In 2016, approximately 1% of the American population had hepatitis C. It's easy to determine if a person has hepatitis C by drawing blood and conducting a test in a lab. However, it is possible to get incorrect results. One commonly used test has a 0.2% false positive rate and a 3.1% false negative rate. Create a tree diagram to illustrate the above information. Okay, so let's first look at what is going on. So the first sentence, 1% of the American population had hepatitis C in 2016. So there are two options here. You either have or had hepatitis C or you didn't. So those are my two branches to start off this problem. So has hepatitis C, does not have hepatitis C. So those are the two options. You either have the disease or you don't. 1% of the American population had hepatitis C. So 1%, if these two branches need to add up to 100%, which they do, you would do 100 minus 1, and you would get 99%. It's also helpful to have this as a decimal, so I would probably go ahead and change it to decimal form. So 0.01 and 0.99. I'm going to use those numbers instead. Okay, so then it tells us it's easy to determine if they have it, but it's possible to get incorrect results. They tell us about a false positive and a false negative. So let's think about what it means to get a false positive. A false positive means you take a test and it says you have Hep C. But that's false. So you actually don't have Hep C, okay? A false negative means you take a test and it says you don't have Hep C, but that's false. So in reality, you really do. So let's see what options we have here. You have Hep C and you take a test. The test result is either going to be positive or negative. A positive meaning you have it, and a negative meaning you don't. Okay? You don't have Hep C, you take a test, and you get results. You either have it or you don't. So the false positive means it says you have it, but you actually don't. So it means you do not have Hep C, but you get a positive result. So that's going to be down here, 0.2%, or if you change it to decimal form, 0.002. So this means you got a positive result, but it was false. You actually don't have hepatitis C. Okay? So it's always going to be the plus where you don't have it. A false negative means you got a negative result, but that's false. So it means you do have Hep C. So maybe my wording up here is not clear. Okay. So the test result says it's positive, but you actually don't have it. Actually don't have it, but you get a plus. Okay, so that's that bottom plus. False negative means it says you don't have it, but you actually do have it, but you got a negative. So that's going to be at the top on the bottom, right? So it has hep C, but a negative. So that's going to be 3.1%, or in decimal form, that'll be 0.031. Now keep in mind the two branches need to add to 100. So for the top, I know I have 100%, and then I'm going to subtract off 3.1%, and so that's going to give me 96.9%, or 0.969 as a decimal. Okay, on the bottom, the plus or minus chart, I know I have 0.2% for positive. So I subtract 100 minus 0.2%, and I get 99.8%. And as a decimal, that's 0.998. So now let's look at all of our joint probabilities. The probability that you have hepatitis C and you get a positive result, we could find that by multiplying 0.01 times 0.969, and for that, we get 0.00969. Okay, now we have that you have hepatitis C, but you get a negative result. So to find that, we would do 0.01 times 0.031, and we would get 0.00031. So these numbers are very small. Notice that if you add those numbers together, the 0.00969 and the 0.00031, you get 0.01. And that's exactly what we have over here on the original branch. So those two numbers, the joint probabilities that you're getting at the right-hand side, those should match that 0.01. Okay, so now we're going to do the bottom. So the probability that you do not have hepatitis C, but that you get a positive result, you could find by multiplying those together. So 0.99 times 0.002, and for that we get 0.00198. Okay, the last option is that you do not have hepatitis C and you get a correct negative result. So you would find that by multiplying 0.99 times 0.998, and for that you would get 0.98802. And again, if I add that 0.98802 plus the number above it, 0.00198, you will see that that adds up to 0.99, which was our original decimal for the does not have hep C. Okay, so there are our joint probabilities. So now we can use that information to calculate the probability that a positive test result means someone has hepatitis C. So a positive test result means someone has hepatitis C. So let's look at the first part. A positive test result. Well, there are two different ways you can get a positive test result. So you can get a positive test result. Let's see, positive is up here, 0.00969, and here. This is also for the positive branch, 0.00198. So those are the two options, 0.00969 plus 0.00198. So if we add those together, we get 0.01167. Okay, now it says means someone has hepatitis C. If they have hepatitis C and they got a positive result, then that would only be the top branch. So that would be the 0.00969. So now to calculate the probability that a positive test result means someone has hepatitis C, you're going to create a fraction out of this. So this is going to be this over this. Let me give myself a little bit more room here. It's going to be 0.00969 divided by 0.01167. And when you do that, you get 0.830. So approximately 83%. So if you get a positive test result, you will actually have hepatitis C 83% of the time.